we're going to do these rate problems. We're going to do some examples. So here we go. So the first one, for the reaction, 3ClO minus goes to 3ClO minus goes to 3ClO3 minus plus 2Cl. Doubling the concentration of ClO quadruples the initial rate of the formation of ClO3. What is the rate expression for this reaction? So we know we're going to start with rate, right? And it's going to be equal to some constant. We don't know what. That's part of the equation. And we know that ClO minus is going to be in brackets. Now, it gave us a clue. What clue did it give us?
Quadruples the initial rate.
So if it quadruples, what's happening? What's quadruple? Mathematical wise. So if I double this, what power does that have to be to quadruple? What does quadruple mean? That's what I'm trying to say. What is it? You guys tell me. So quadruple, so if I times this by 4, or to the 4th power, whoops, this is the same power, same. Oh, not 9, sorry. 2 times 2 is 4, times 2 is 8. Thank you. Okay, so if I quadruple it, that's basically saying 2 to the 4th. That, by the way, this was 2. That would be 16, right? I don't know. Is that quadrupling?
Mm-hmm. Wait, because you have quadruple.
Okay, so to the 4th power, that's 4 2s. 2 times 2 times 2 times 2. That's yeah.
What? That doesn't make sense.
2 times 2 equals 4 times like multiple.
But I've been getting my math questions right in math. So
they're just thinking about it too hard.
Okay, if I 2 times 2, that would be doubling it, right? Okay, Josh, what do you think?
It's times 4. Yeah, I told you. Goodness. It would be times 4. Goodness.
Okay, but it's what we're trying to solve is this power. We want to know what that power is. If at the end, we get something that quadruples the initial rate. So quadruple, we decided is what? 4 times? 4 times the initial rate. So whatever the initial rate was. That's, yeah, this is all in number 1. I just didn't have enough room. Okay? Okay, so if it's 4 times, and I doubled this, so if I doubled this, what power, I used x, I shouldn't use x, 2 times ClO minus. If I 2 times that, and it's still to a power, and it equals 4, what does x have to be? And this isn't x, this is 4 times the rate. So what does x have to be? It has to be 2, right? It has to be 2, because 2 to the 2nd power, which is just 2 times 2, makes it 4, right? So my expression that I write here is that, done. So you just got to be able, this would be like a multiple choice question. You need to be able to look at it and say, okay, if it quadruples, that means it's 4 times. So 2 to what power gives me 4 times? 2, right?
Oh my goodness.
Because all I did was put in here 2 times what was there. Get it? Okay? If you don't, you're making it too hard. You're making it too hard.
We do that with everything, though.
I know. I know. Okay, so let's go down here. Number 4, yep, that's where I was going to go. The overall rate is just adding the exponents together. So let's do C. So what would be the overall rate of C? 1.5. Because there's a 1 right here, and there's a half right here, so the overall rate is 1.5. Or we could write 1.5.
4/1.
Okay, so let's go on and look at some others.
Number 6. Up front.
Wait, no, okay, number B on 4.
That's just
Yeah,
one.
that's
No,
it's not
It
one.
is 0.
it's zero order. It's zero order, yep.
There's
Because,
no reaction.
well, anything to the 0 power is 1.
1.
Is 1. Anything to a 0 power is 1.
Oh, so you're finding it.
Right, you're trying to find the power. So let's go forward
Yes,
and look at some others here.
See, I'm understanding this already.
Good.
Goodness.
Yes.
Miracle. Crystal,
Okay.
Miracle. Decomposition of, are we not doing 5?
I'm not going to do 5 or 6 because that just, you're writing the rate law again. Same thing on 7. It's just asking you what to do, what happens.
Is first order with respect to each reactor student?
Okay, so if it's first order with respect to each out, so what's my rate expression? Rate equals what? K.
No, K. And no 2.
It's ones. You don't write exponents of ones, right? That's pretty easy. So how does doubling NO2 affect that reaction rate?
Hold on, sorry. Hold on. Let me figure it out.
In that equation, if I double NO2, what happens to the rate? Times by 2, it doubles. Okay, what happens if I triple the rate of O3? It triples, yeah, because they're ones. Not a big deal. Okay, this first page is just think it through. Okay, just think it through. So I'm going to go on to the next page where we actually get some data, because that's where we're talking. Yeah.
Back of the first page or on the
Yeah, on the back. I think it's the back.
Yes.
I got.
We're not doing. Let's do 11. Just doing 1. That's fine.
Back of the first page. There we go. Yeah, 11.
Just kidding. Let's do 11.
Okay.
Okay. So you do rate. Determine the order with respect to each reactor.
Okay, so these are 4 things we need to do with this. We need to set it up first. Does anybody remember from last time what we need to do to set it up? It's not ice. This is rate. So all of these are going to be rate equals some constant, right, times the concentration of A times the concentration of B, and each of these are to some power. We don't know. We're trying to find it, right? We got to figure it out. So what we want to do is we want to look and say, oh, A's held constant here, and B's held constant here. And I just got out of calligraphy. Darn it. I like it when it's littler. Okay, so basically what we can do is say, okay, I can take one rate, and then I divide it by another rate, divide it by another constant, and the same things like this. And if I hold A constant, then A will drop out and K will drop out of the equation, right? And I can solve for B. If I hold B constant, B will drop out of the thing, and I can solve for A. So let's write it like we would. So let's pick the first 2. I'm going to write it the long way so I can show that they're dropping out. So I'm going to say rate, which is 0.470, is equal to some constant times the concentration 0.720 to the x power and 0.180 to the y power. These are each divided by the next one down, which is 0.720. Okay, and then I'm taking this row right here, the second row, and I'm putting that in. So I'm going to have 0.720 to the x and 0.720 to the y. Now, at this point,
Wait, you did it wrong.
oh, sorry, this part right here. This should be, sorry, I looked to the wrong place. 1.880. Okay, so now at this point, I can cancel out the things that are the same. The k's will be the same. They're gone. This will be the same. It's gone. Okay, so I'm taking you through it. This is how you would want to write it on the AP exam so they can see what you're doing. Okay, so now I'm going to rewrite what I have. So 0.470. Yes, let's solve it. Solve this side real quick.
So, wait, that's really easy.
Here's my phone, here's my keys.
It's 0.25.
Oh, they're back in the bag.
Oh, you're fine.
Actually, I've got one right here. It's 0.25? 0.250 because I have 3 sig figs. Okay, do 0.18 divided by point. So basically, I'm putting both of these inside like this and bringing the y out. So it was 0.25 on this side too? Well, this is really easy because to what power do I need to get 0.25 to get 0.25? If it's 0, it goes to 1. So I want it to be 1. So I can just say really quickly, y is 1. So I've got that one done. I know what its power is. Just a little bit, not very long. Okay, so now I'm going to take the next two, and that is the green ones, and I'm going to do it with them. So I've got 0.470 equals times the concentration of 0.720 times or to the x and 0.180 to the 1, which I don't have to write 1 because I already know y now. But I could put y there if I wanted to. Doesn't matter which one you do first. Nope. 0.117. Need the rate first. K equals 0.360 to the x times, and this is all divided by the way, 0.180 y. Now canceling out what we already know. You can just leave it as 1. You solved it first, but it doesn't matter which one you're doing first is what I wanted to show you. You can still solve. Okay, so on this side, 4.0, whoops, I can do zeros. Okay, equals, again, these will all go underneath with the x outside, so we could do like this. 2 to what power gives me this? So now how do I do it?
You just trial and error.
It's about 2. We can say it's about 2, but if we want to find the exact number, because sometimes they don't come out just perfect, how would I do it? So I have 4.017 equals 2 to the x power. How do I get the x down?
ln and log.
ln. So we're going to do ln on both sides. So I'm going to take and ln both sides. When I do that, on this side I'll get ln of 4.017. On this side it becomes x ln of 2. Because the exponent will come down in front. Okay, so then if you divide both sides by ln of 2, x will equal what? I'm holding.
Divide by ln.
Still don't understand that joke.
Wait, so how do you put that in your calculator though?
So you have ln, there's actually a
So you just do ln.
ln of 4.17, 0.017, get an answer, divide ln to and
Can you
parentheses.
show that though?
No, you can show this part that we've got up here. That's enough.
And then you divide it by.
Divide it by parentheses ln of 2. 2.006. So basically 2. If we wanted to, we could round up because we've had 3 sig figs. So we could say x is 2.01. Okay.
Oh!
Now
We're done.
we have determined the order with respect to each element. So with respect to
Do you have to end with,
B, the order is 1 or first. With respect to A, the order is 2. So you would write that out. Don't just stop.
so.
Okay, so
Can I just put like, can I put like this section is A, this is B section, is that okay?
you still gotta still, because it's asking with respect. So you gotta go with respect to,
If I can organize it a little bit better.
yeah. With respect to A, the order is okay, so then it asks us what?
Wait, what was the first one?
1. The overall order. How do we get the overall order? So this was all A that we did over here. So over here I'm going to do B. So the next part really doesn't take that much space. All I have to do is go overall order equals 1 plus 2.01, which is 3.01. Done. Okay, and the next one they want us to do what?
Wait, how is that?
You just add the two orders together.
Expression for the reaction.
So the rate expression for the reaction now then is rate is equal to K times the concentration of A times the concentration of B. And which one was the X? Was it A or B? A? So 2.01 there, and just B would just have it by itself. Now usually at this point they'll have you solve for the
Find the value
of
the
K.
rate constant.
So now we got to go back up and pick one of the
Let's pick the 1, 1.
these going across the 1, 1. Okay. So the rate is, so this is D. The rate is 0.470 is equal to some constant K times the concentration of 0.720 to the 2.01 power times 0.180 to the first power.
Okay.
Now,
So-
now we're solving for K, right?
Why are we using 2.01?
Because that's what we got.
That's what we solve for X.
Now you're sitting down, so now you're not kidding.
So.
If you want to, you can put a chair up there so you don't have to lean over and you write on the desk so it's up higher so you can write.
Yeah.
Yes, and then put your paper on the chair.
So.
That turn is sideways.
Maybe it's
Okay, so here we go. We're just plugging this in. So we're going to get 0.470 divided by the quantity, 0.720, 2.01, and 0.180. These are molarities over here. And this one was, what was the units on that rate? Moles per liter second. So this one is molarity times second to the minus 1. So we've got it, and this is all equal to K. Molarity times inverse seconds. Yes, I do. Thank you. Okay, so now I just solve for it. Me, personally, I do the bottom first, then hit 1 over X and put it on the top to get the number, so I don't screw up. You have 0.05? 5.05. And the units, we would have M times minus 1 second all over molarity to the 3.01, right? So I'm going to take 1 molarity out. And so then I would end up with molarity to the minus 2.01, second to the minus 1. That would be my units.
5.5, yep. Whoa, you got so much more. Hold on. Slow down.
All I did over here is just deal with the units, because sometimes you have to just pull them aside and do them separately because they get really hairy, but they do usually give you a point for the units.
Why do you put it like with the negative? Why don't you just put it under?
I could put it under or 1 over m to the 2.01 s.
But they don't.
I said 3.01.
Because this is squared, right? So you add exponents. So this is a 1, and that's a 2.01, so you get 3.01. Okay, we're not circling or squaring any of our answers, right?
Can I use line to divide up like where I did PC?
That's great. That's great. Okay, so this is what you're going to do on the others. 12, I tried to give you enough room. 13, 14, 15, and 16 sort of got smashed together.
Oh, great. We need extra.
However, the third page that I gave you, third page doesn't have a back, and I printed 16 again on it. So you could cross 16 off that other page and use it to continue 15.
Oh, just cross off this 16 and separate on.
That's what I mean. That's what.
And these ones?
Okay, so let's go on to the other ones down at the bottom. 17 through 21. So 20, yes.
I was like 21.
21. I'm going to make it up and give it to you. Okay, so
9 plus 10. You gotta say it right, or else then it doesn't make sense. 21.
19, 18, 19, or 20. Pick one.
920.
920. What's happening? I wasn't listening.
Shame on you.
Okay, what just happened?
No,
What
let's
were we
do
talking
20
about?
because 20 is the last one, so that way we get to the end and we're like, boom, don't have to do 20.
Yeah.
Then it's like,
That-
you get to
that actually
19
makes me
and it's
feel
like, oh,
really
now I
good.
can do
I like
20.
that logic.
I really.
Okay, let's do 20 then.
Oh,
Okay, so, supposed to be 0.0.
I think I'm actually gonna finish this one.
Yeah, this should have been 0.047. Actually, I think it's supposed to just be 0.47. It's supposed to be 0.747. I'm just looking at what B is, and that concentration makes more sense. Okay, so here we have, consider the reaction. Okay, so
First order, and A,
in A, add.
and add first order in B.
Okay, guys, focus.
Rate constant.
Stop before you go farther. Okay, the rate law for this reaction is first order in A and first order in B. What can I write right now in the rate law? Right, so I know rate is equal to, the next sentence gives me K. Or the last, yeah, if the rate constant is, so I can go ahead and put in K right here. 3.01 times 10 to the second. Okay, then I can say, okay, concentration of A is first order, so it's going to be a 1. I got the concentration of A.
Oh, wait, so K is.
Because remember, just a generic one is rate is equal to constant times A to some power, B to some power.
I should have known that from last year.
Okay, so, and then we've got B is also first order, so we're going to times it by 0.79. Okay. And remember, both of these are molar M's. And so all we have to do is plug it through. Chug, that's it. Plug and chug.
3.01. Where's EE? There's second EE.
Good.
To the second.
Okay, that's all I'm going to do for you. You're going to do the rest on your own or with some help if you need, if you get stuck. This is due next time.
Did you guys get
This
one?
is due next time. So if you want to finish your lab, you can finish the lab. If you want to work on this, you can work on this. Your kinetic equilibrium questions need to be turned in.
Yeah.
Okay? Those need to be turned in.
So what are the units on that? Is it m
So it would be m squared
squared?
divided by s, or times s to the minus 1.
M.
You get grace cards, but I am holding them, so I didn't have to print them, so I didn't waste paper.
Okay.
So I'll just write grace 1, grace 2,
You say just
grace 3, you're done. Okay?
How do we do this picture?
So look at the picture.
Pictures.
Oh, that. Look at it.
Okay.
Okay, now think about it. If it says k to the 25, how do I make k for this reaction?
So these.
Write me expression for k for this reaction.
So just draw these two. So K is.
You can call these A, B, C, D if you want to. That makes it easier.
Wait, what shuts down?
It's C.
Yeah, your stomach is constantly working.
D.
It works
Over
even harder at night.
So is that like a common myth
B,
that
right?
like
Right. Now you got k is equal to 25, right? Oh, let me stop this.